Hey everyone, so this next lesson is about congruent triangles, and so for the next few classes we'll be talking about congruent triangles, but this is kind of like the introduction to it. So first of all, triangles are congruent if they are the same size and shape, so everything about them is identical. When triangles are congruent, you can write something called a congruent statement. That's what this is right here. So a congruent statement is just stating that the triangles are congruent. One thing about a congruent statement, though, is the order that the triangles are listed in, the order that the angles are listed in the triangles. So see this order ABC and this order DEF. It does have some significance. So basically how it works is the first angle that's listed in each triangle, so in this case, A and D, that means since they're both listed first, that angle A is congruent to angle D. So you can mark that. Down over here, I'm going to list them as we mark them. So angle A is congruent to angle D. Okay, notice that B and E are listed second. So that means that B and E are the same. Remember when we mark, we use the same number of tick marks. So one tick mark would mean that A and D are congruent. And then if we want B and E, we can't use one, we have to use two, or really any number. You could do 5 tick marks or arcs if you want to. And then lastly, C and F are last, so that means that C is congruent to F. Okay, so then to do the sides, you can use the angle markings to do the sides, or you could use the congruent statement. So see how AB, so with segments, with sides or segments, remember it's 2 letters. So every pair of 2 letters would make a segment. So like segment AB and segment DE are both listed first. So AB and DE would be congruent. Another way to think of it is AB is on a side that has 1 arc and 2 arcs, and then DE is also on a side that has 1 arc and 2 arcs. So you kind of use the markings as well. Or you could use the congruent statement. So segment AB would be congruent to segment DE. Okay, and then see how BC and EF are last? So that means that BC and EF are congruent. And then lastly, well, obviously the only ones left over, but you could say like A and C and D and F. So segment AC, segment DF. You do 3 tick marks because those are first and last. So that's how you would take a congruent statement and identify all of the corresponding congruent parts. This little box here where it says congruent statement, I just wanted to talk about how there are multiple ways that you can give a congruent statement for every pair of congruent triangles. Basically what you do is you pick an order for the first triangle. So I'm going to do a few other examples here. So something, we already did ABC order, so we're going to do something other than ABC. So like let's say instead of ABC I did CAB. To figure out the corresponding angle in the other triangle, you have to match up the order. So C, I did C first. C is congruent to F, so that means F has to come first here. Then I did A, which is congruent to D, so then D would come, and then B is congruent to E. So that'd be another way you can do the congruent statement. I'll do one more just to show you. So like say triangle BCA. I started with B, which is congruent to E, so E would come first here. Then I went to C. You could also, I kind of like encourage kids to do this too. Like if you trace from B to C to A, from 2 arcs to 3 arcs to 1, 2 arcs, 3 arcs, 1, E, F, D. So that's another way you could look at it. It's using the markings and kind of like tracing the triangle. Okay, so CPCTC right here is something that we actually do use a lot when we do proofs. It's kind of like the formal definition of congruent triangles. So to fill in these blanks, 2 triangles are congruent if and only if their corresponding parts are congruent. Whoops, I forgot the S. CPCTC stands for corresponding parts of congruent triangles are congruent. So when we actually use this in proofs, I will kind of like bring it up again, but basically it just means that if you're told that two triangles are congruent, like we were told over here, that these ABC and DEF were congruent, if we're told that two triangles are congruent, you can then say that all of the corresponding parts are congruent. So that's what CPCTC stands for. Why does that keep happening? Here we go. Okay. So for an example like this, it says for each pair of congruent triangles, name all pairs of corresponding parts. I'm just going to label them just to save time, but it's basically the same thing that we did up at the top example. But these are in different, like each triangle's like in a different orientation, like they're not facing the same way. So sometimes it can be a little trickier. So I'm going to start with W and G. They can get one arc. V and H, they can get two. And then U and I are last. Then we can do segments. So see how WV is on a side that has one arc on one side and two arcs on the other. So you want to look at the other triangle and find one that has one arc on one side and two arcs on the other. So that would be HG. So that'd be another way to identify them. Or remember, again, you can use like the order. So VU and HI are going to be congruent. And then lastly, WU and GI. Okay, and that's because of CPCTC. Corresponding parts of congruent triangles are congruent. Okay, let's do the last one on this page. So we have G and L, F and K, and then E and M. Okay, then we can do the sides. So see how GE is on one arc, has one arc on one side and three on the other. So one arc, three arcs would be here. Then let's say this one has one arc, two arcs. Where's one arc, two arcs? That's here. So LK and GF would be congruent, and then therefore EF and MK. So that's how you would match up the corresponding parts. And then the last part of this, actually, just kidding. There's two more things. This part is just practice with giving the congruent statement, like filling it in. So if I went from C to D to B for the first order, so starting out the angle with one arc, whoa, it's not what I wanted to do. Starting with the angle with one arc, then going to two, then going to three, same idea, 1, 2, 3. So it's going to be triangle CDL. BDC is next. So from one arc to two arcs to three again. So 1, 2, 3. It's going to be MLK. Okay, MKL. One arc to two arcs to three. So MKL. 1 to 2 to 3. So triangle STL. And then last one, JIK, again, 1 to 2 to 3. It's not always like that. Like I could go 3, 2, 1. The order that you do it in doesn't really matter to start off with, but it's important that whatever order you choose for the first triangle, you match it up for the second triangle. So JIK, 1, 2, 3 would be JCD. So you just want to match up the markings. Okay, and then the last thing is, this is also pretty easy. Some algebra problems. So basically you're given a pair of congruent triangles rather, and then you're given some information about it. And then it says draw and label a figure to show the congruent triangles, find the value of X and EF. So really you could do this without drawing a picture, but I'm just going to draw a quick picture anyway, and I'll show you how you can do it without drawing a picture as well. Okay, so let's pretend that those are congruent. I tried my best. So you have ABC, and then D, E, F. So A and D are congruent because those are first, B and E, C, and F. So then therefore this one and this one, this one and this one, this one and this one. And also label it with all the given information. So BC is 12, AB is 10, AC is 6, EF is 2x minus 4. So basically you just need to figure out, well, it's already marked, so it's kind of easy to figure out at this point, but look at the side, or sometimes it's angles. Look at whatever piece they gave you that has an expression in it, like a variable. So EF has 2x minus 4. So we need to figure out what side is equal to EF. Well, I already labeled it. It's BC. So all you have to do is do 2x minus 4 equals 12. And then solve. So 2x equals 16. X is 8, pretty easy. And then EF is 12. Now, how we could have done this without drawing a picture is just look at all of the given information, look at whatever one has a variable, EF, use the order to figure out which one EF is congruent to. EF is last, so is BC. So I could just know that I'm going to set this equal to BC. So you can do it without drawing a picture, but sometimes it's helpful. So that's it for congruent triangles. Your practice today is there's one paper on this, and then I'm having you going back and do the evens from yesterday. So please let me know if you have any questions. I'm available during ACT Lab today from 1:05 to 1:55 on the ACT Lab link. You can also email me throughout the day if you need help. All right, that's it. Have a great day.